We are really thrilled to have Dr. Joel Kearns with us this afternoon. Dr. Kearns currently serves as Director of Facilities Test and Manufacturing at our own NASA John Glenn Research Center. There, he is responsible for the facility's infrastructure and maintenance on all the test facilities on the entire campus. He's responsible in the past for flight research, and he has a very long career at NASA here at Glenn, and he's overseen space flight systems. He's worked with the space shuttle, with the Orion crew vehicle, and I'm going to be totally honest, Dr. Kearns, you've worked with a lot of things that I don't even understand. So we're looking forward to you shedding some light on this for all of us who need a little education in this area. He served nationally in very prominent roles and has really helped to advance our space mission. In 2009, he was the recipient of the Presidential Award for the rank of Meritorious Senior Executive, a true honor and distinction, and he is the holder of 4 patents, and I'm sure there's more in the offing. So with that, Dr. Kearns, thank you for joining us, and we look forward to hearing your remarks.
Oh, thank you so much for having me today. So I am Joel Kearns, and to give you a little bit more background than just what jobs I've had in the past, I'm a material scientist by training. That means I'm a designer of new materials, and I have designed experiments on materials in space over my career. When I've been outside NASA, I've also designed materials for computer chips. That was one of my specialties, like the kinds used on laptops and cell phones, as well as for solar cells that are used on Earth, not just in space. And I moved to Cleveland in 2013 to come work at the NASA Glenn Research Center, which is a really worldwide recognized research and development site of NASA. And before that, in addition to working in industry, I also worked at other NASA centers. I worked in Alabama and Silicon Valley and also Washington, D.C. So thank you very much for having me today. What I was going to talk about was what is NASA doing and why to send people further and further away from Earth into space. And in particular, to talk about our big goal in the near term, which is to get people back on the surface of the moon in 2024. We call that Moon to Mars. So I put up a chart to show you here, which is what are we at NASA Glenn Research Center? We have 2 campuses. One is right next to Cleveland Hopkins Airport. And we have about 3,000 people, both government and industry people, that work on science and technology right next to the airport. And we have another campus in Sandusky, right south of Cedar Point, where about 150 people work on big spacecraft and rocket testing for the United States. Many of our people are engineers with advanced degrees, but we also have people that are machinists and people doing other types of fabrication to build things. A lot of the work that we do, although we do it here in Ohio, we do it really closely with other groups around the United States and the world. We will have projects where we are working, parts of them in Ohio, parts in California, Texas, Florida, Colorado, Germany, Japan, all over the place. A hallmark of the work we do is we do a lot of work locally, but that work is all connected all around the world, and it's usually being done with colleagues, all around the world. Now, this particular site, which is now called the Glenn Research Center of NASA, was actually built during World War II to start engineering development of engines for airplanes and jets. And over the years, it was taken over by NASA when NASA was formed in 1958. And since the time, it also broadened into space work, although we still do a lot of work in aeronautics and airplanes. I'm not going to talk about the aeronautics work today. So let's talk a bit about why are we in space and where are we going and why. When most people think about people in space, and I'm going to talk today mostly about people going in space, they think about the space station, the International Space Station. It flies about 200 miles over our head, so it's actually pretty close to Earth in space. People used to think of the space shuttle that would fly missions, but the space shuttle flew its last flight 9 years ago in 2011. And since then, the American astronauts that go on the space station actually fly on Russian rockets out of Russia to get to our space station. There are usually 6 astronauts up on the space station at any one time. Right now, we have 3. And this year, in 2020, is the 20th anniversary of continuous staffing of astronauts and cosmonauts on that station doing work for the United States and other nations. So I want to remind you why it is we do this work on the space station. From a big picture point of view, remember that we're in space, not just the people on the space station. Earth is in space. And although we always, we look around the way we're brought up and we think that Earth is separate from space, we are in space. And every so often we get a big reminder of that, like when a meteor comes down and blows a hole in the ground, or you see a meteor come flying into the atmosphere. I remember a couple of years ago in Russia, and it lit up the sky and people wondering where it was going to land. But most of the material and energy we know, meaning like almost all the material energy we know of, is actually not on Earth. It's off in space. That could be anything from solar energy. It can be precious metals. It can be actually oxygen that's bound up in rocks. There's actually more of that away from Earth than there is on Earth. So what we want to do at NASA, we have lots of different goals, lots of policy we get from our elected representatives. But what really drives us is we want to try to bring that wealth to be able to be used by the United States and the wider world, in addition to the United States. We already take advantage of getting value out of space already in what we call near space, say where the space station is, or just a little further than that. For example, a lot of our communications goes through communication satellites that are unmanned that fly around the Earth. That's probably some of us logging in today by telework to be on the Zoom call. Even though it's all local, it might be going through a communication satellite to get there. We have weather satellites to let us know when the storms are coming to keep us safe. We have the maps on our phones that come from a satellite system called Global Positioning System that tell us where we are on the roads. As a matter of fact, even bank automatic teller machines go through satellites in order to synchronize all the times to make sure that the computers know when it's okay for you to access your money or whether someone else is trying to access it and you don't want to give them that. So we rely on space for a lot today. What I put here to show you is this is the photo though where we have people right now in space, the International Space Station. It's the biggest thing ever brought into space. It was brought into many pieces. It's about as big as a football field. I think it weighs about 500,000 pounds. And on the left, you can see the space station and you can see the big wings on either side, which are actually not like airplane wings. Those are the wings where the solar cells are that soak up the sun and convert all the sun to electrical power so that you can power the space station, keep everybody healthy. Glenn Research Center at NASA is world renowned for not only planning experiments that are done on the space station, but also we are the ones that put together and worked with industry to build all those power systems, those big solar wings that you see on the other side, and do all the power that is used on the space station. One thing I put on this picture of space station, as I said, has been up there with people this year for 20 years. One thing that's new is next Wednesday, we're gonna have the first flight of an American-built ship to leave the United States and carry 2 astronauts to start being able to bring our own people up to the space station since we flew the last shuttle flight in 2011, 9 years ago. We had SpaceX, a relatively new company, built the ship for us. It's gonna fly up 2 NASA astronauts for the first time leaving Florida in 9 years on next Wednesday. We have another company, Boeing, building a different ship that's being tested, and they will probably start taking people up later in the year or early next year. So you should watch for that on Wednesday for the next thing where people are going to leave the United States and go into space. So what do people do in the space station? Here's a photo of inside the space station. It looks like a really complicated laboratory, and it is. It's like a big university lab, but it's the university lab where we can do things in weightlessness, which is something we really can't simulate for any type of long period on Earth. The equipment shown here behind the astronaut is pretty complex, and it was actually designed here in Cleveland. What I'm showing here is equipment that's being used to do research on fire and burning, which you might wonder, well, why are we doing that in space, besides wanting to make sure nothing burns in space? But it turns out by taking away gravity, by doing things of weightlessness, we can actually simplify a lot of very complex science problems and learn about them faster if we actually go do them in space. Burning and fire research is one of our specialties at Glenn Research Center in Cleveland. And we actually built the equipment with industry that's shown in this photograph. We have a little mission control center in Cleveland where we actually have scientists operate the experiments with the astronauts. And we have a copy of all the equipment up on the space station right here in Cleveland. So if something goes wrong or we're thinking of changing it, we can actually go back and modify it first in Cleveland and make sure the astronauts are clear with what to do. And then we can walk them through how to do it. But one of the reasons, I'll just say a few things about the fire research. One of the reasons we're interested in that We think about fire as being, well, something bad happens, there's a fire, but remember combustion, which is the chemical process that makes fire, is also used to make power on Earth. It's our internal combustion engines in our cars, using gasoline. We're very concerned about how much it makes pollution or how efficient it is, how much energy you get out from, how much energy you put in. So looking at fire and combustion is a really big high value research opportunity, both for in Earth and in space. And in addition to doing these fire experiments at the International Space Station, we do them on other spaceships also. We did a fire experiment last week on a ship that just left the International Space Station, an unmanned ship to bring cargo back to the Earth. But we have been really limited to being just near Earth since 1972. The reason was after we sent people to the moon from 69 to 72 for the initial exploration, it was a pretty expensive thing to start up back then. Technology wasn't nowhere near as advanced as it is today. It took a lot of people, but more than it would even take today. We didn't have advanced materials. We didn't have the computers we have today. And the country was at loggerheads over the cost of the Vietnam War and other priorities. But this is a very famous photo I'm showing you on the screen. You should be able to see the Earth over the moon. This is the famous Earthrise photograph taken by the first crew of astronauts to ever go out to the moon and look back and see the Earth. And it really kind of shocked people at the time because it showed how small the Earth was. It was the only thing with color out there that they could see from that view in space. You can see the moon is all gray or brown. And it really brought home to people that that's where everybody lives. And we better do our job to take care of it. And that's one of the things that led to Earth Day that we just celebrated back in April. But the moon is pretty far from Earth. I said earlier, the space station's pretty close to Earth, even when it flies around, even though it's in space. Earth is about 8,000 miles wide, in diameter. The station only flies about 200 miles above the Earth as it goes around in the Earth, and everyone's weightless. And they are out in space. There's no air. They're not connected to the ground. They're just flying around the Earth. But what it means, because they're only 200 miles away, is that it only takes about, on a rocket, 10 minutes to get from the surface of the Earth to get up to that high speed, 17,500 miles an hour, so that you can be in orbit and you can get to the space station. And it also means it only takes about an hour to get home if something goes wrong. And the reason it takes an hour is we actually use air friction to slow down coming back from that speed to get to the Earth. We don't bring another rocket to slow us down on the way back, right? So it takes about an hour to get back. You'd want to pick out where you want to land. But the idea is if something goes wrong, you can get back in about an hour and a half, safely. If you want to go out to the moon, though, it's quite a bit further away. The moon is 250,000 miles away. It takes 3 days minimum to travel from orbit around the Earth to get into orbit around the moon. It is a long way away. And that means you have to bring, again, just like you do on the space station, you have to bring everything you need with you: air, power, food, water, anything else you need, shielding from radiation, the ability to keep you at the right temperature. If something goes wrong, it takes a long, long time to get back home. And some of you probably remember one of the Apollo flights had a big emergency where there was an explosion on the way out, Apollo 13. It took them days and days and days to get back to Earth, keeping the crew alive. So you really want to make sure, and you really want to make sure you can safely get there. It takes very particular equipment to get all the way out to the moon, and particularly to land on the moon. So our goal right now at NASA, our near-term goal I'm going to talk about, is to land the first woman and the next man on the surface of the moon by the year 2024, only 4 years away. Why? Well, again, a number of reasons. We want to get access to those materials and energy that are out at the moon. We want to use the moon as a staging base to learn about how to work further and further away from Earth so we can eventually go to other destinations that even have more valuable materials, like Mars or the asteroids that are in orbit around the sun. We know there's good scientific research that we could do with people if we got on the moon. It's actually different than the type of scientific research you just do in orbit around the Earth. There's also competition with our potential adversaries. We don't want to be shut off by our adversaries in the future if they get there and then they don't want us to get there. And also we know that we will have to develop technology to do this, particularly to do it even with our more advanced technology we have today in the United States. And whenever we develop technology, we get a lot of benefit from that we can spin off into other areas. That's what happened in Apollo, and it will happen now when we go back to the moon. We call the new effort to go back to the moon Artemis, which is the name of the sister of Apollo. in Greek mythology. Apollo was our program originally to send the first people on the moon in the 1960s. And this time, using advanced technology, the big difference is going to be we're going to live off the land in the moon. We're not just going to go there and visit and have to come right back, but we're going to find ways to self-sustainably live there. So here's an image of where the first people are going to land when they go back to the moon. They're going to go back to a very different place than the original Apollo astronauts went to. They're going to go to the lunar South Pole. Why are we going to send them there? Because we know that frozen water in the form of ice is there, and we can use that ice to make air, to make drinking water, to make rocket fuel. That's our strategy to be able to live off the land. And what that's going to mean is we don't have to take everything with us for every person every time we go, unlike Apollo. We know the ice is frozen deep in shadowed craters. We have actually crashed spacecraft into those craters to blast the ice out of them to prove it's there. I got to work on that project about 10 years ago. And we all thought the ice was there, but we actually didn't know till we crashed the ship into it and was able to see it spray up from the moon. These craters are big. If you see on this diagram, the big crater that I'm showing in the middle called Shackleton, it is bigger in area than Washington, D.C., which we show here in the diagram as if we transplanted Washington, D.C. to the crater. It is 4 times as deep as the Grand Canyon, and that's where we know there's a lot of ice. There's ice in a lot of the other craters too, we can tell from our remote sensors. So that's where we're gonna go. We're gonna probably start off going outside the crater, and then we're gonna start going into the crater to get those resources. So how do you have to get to the moon? As I said, we don't have the space shuttle anymore. The space shuttle, by the way, could never get to the moon. It was only built to go up into near Earth orbit, like the space station's orbits, and come back. To get to the moon, you need an even bigger rocket than the ones that we are building, like SpaceX is building to get our crews out to the space station starting next week. We need a big rocket, and we need a spacecraft that's specially designed to keep people healthy all the way far from Earth. That is shown on the left in an artist's concept, the Orion spacecraft, and what's called the Space Launch System rocket. And on the right, I'm showing you a photo of the very first Space Launch System rocket, which has been taken from its construction site in New Orleans and is now in Base St. Louis, Missouri, Mississippi, where the engines are going to be test fired before we bring it to the Kennedy Space Center later this year, set it up on the launch pad like it's shown on the left, and get ready to fly the first test flight into space. The first test flight is going to be unpiloted because we're going to really wring out the rocket and the spacecraft through its paces. It's going to fly out even further than the moon before it comes back. It's going to stay out there a month so we can make sure everything operates the right period of time. And then the second flight, which will take place after 2021, that's the first time we're going to send people back to orbit to go around the moon. Very much like the first flight that took people at the moon and didn't land, but gave us the Earthrise photo. So Orion is built specifically to go way beyond Earth orbit, to go what we call beyond Earth orbit, or BEO, way beyond where the space station is, to go out to the moon. It could go to further destinations, Mars, eventually the asteroids. That means you have to bring a lot more air, a lot more food, a lot more drinking water. You have to be able to scrub your air so that when you breathe out into the air, it can scrub out all the carbon dioxide that we breathe out. You also have to be able to withstand higher levels of radiation. You need more shielding. And it means that when you come back, coming back to the Earth at a much faster speed from much further away. So Orion was designed specifically to do that. You can see a diagram of it here on the left. It looks very different from the space shuttle. It's kind of like a gumdrop capsule where the crew is. There is a cylindrical looking what's called service module, which has all the power. It's got little solar arrays you can see in blue on this. That's where all the water is. That's where all the air is in the service module, rocket engines, communications equipment, et cetera, et cetera. And if you look on the right, that's a photo of me standing in front of the very first Orion, which is the one that's going to go out on that moon flight in 2021. And this was when we just finished testing it in Sandusky, just south of Cedar Point, from November to March this year. Right before the state went into stay at home, we got the testing done and shipped it back to Florida to get ready to fly. It passed its flight in flying colors. It's all ready to go. We got to finish testing the rocket before we can actually fly it. So we're ready to at least start getting back to the moon. Now, the last part that you need to get to the moon is a way to actually land on the moon once you go all the way out to the moon. And this is what NASA calls the Human Lander System, or HLS. We don't have one today. NASA just picked 3 companies to work with to design a lander. We picked 3 because the company's ideas were really, really different. We're not quite sure which one will actually be ready for 2021. They have different advantages and disadvantages. All 3 are not only going to be built by industry, and industry builds most of the equipment NASA uses. We build some within NASA, but we actually work with industry to have them build a lot of equipment for us. But what's going to be a little different compared to the last lunar landers is that the industry is actually going to own these landers, and we are going to, in effect, be renting them like rental cars, to go down to the surface of the moon. And that's actually very similar to the SpaceX and Boeing work I talked about earlier to bring people up to the space station. They actually own those ships. We co-design them with them. We make sure they're safe at NASA. We make sure they pass all our needs. And we have to be satisfied before we put people on them. They're going to function okay, but we don't actually own them at the end. It's actually the companies that own them. And hopefully the companies will be able to use them for their own work on the moon someday also. I'm going to show you what some of these ideas look like for these 3 companies that have proposed building landers for the moon. The first one that's shown here is from a company called Blue Origin. They're a relatively new space company. They've been around about 5 years, 6 years. They're owned by Jeff Bezos, who owns Amazon and also the Washington Post. They put together a big team of companies across the United States. They're going to do some and run the whole thing. They have other major companies doing other pieces. They're going to use up-to-date technology and materials, but they have a kind of Apollo-type lander design, although it's bigger. It will land in one piece, and then the top piece, when the mission is done, will take off and fly back up to rendezvous with another ship, probably the Orion ship I told you about earlier, which would then bring the astronauts back from the moon when they're done with each mission. And the bottom part, it would be like a landing pad and a base, and it would stay on the moon. It could be used in the future. Here's a second one. This is proposed by a company called Dynetics, a company that's been around actually for 20 years and has also built space equipment. You can see it looks very different. It comes from a different group of engineers. They have different advantages and disadvantages. This one is a little bit closer to the ground when it lands. It has different pieces that it splits up differently when it takes off. This one uses solar panels to get energy, which we should be able to do at least outside the crater on the South Pole. But you can see it looks very different from the first one I showed you. And it's very different from the last time we did it for Apollo. And the third thing is from, concept is from SpaceX. SpaceX is already working on a big new rocket called Starship that they would like to use to send people up into space and eventually to the moon, eventually to Mars. And they propose that NASA work with them to help finish Starship and get it ready to go to the moon. And we have agreed to do that in terms of them, if they can make progress getting it done to meet our goals to land in 2024, we certainly will work with them. And at this point, we don't know for these 3 different ways of doing the lander that I've shown you, which ones are actually going to get 100% built and which ones are actually going to be the one on the first landing in 2024. But we are pretty sure it's going to be one of these 3. And all these teams are very enthusiastic and motivated. They all want to be the people that get the first woman and the next man back on the surface of the moon on behalf of the United States. So there are more elements, though, besides that. If we always took a lander each time, maybe disposable lander out to the moon over and over again, it would be very expensive. So we are working with the companies to make ways to make the landers reusable. And if you're going to do that, you need a place to stage them, clean them. You need refuel them. You need a place to make them ready. You need a garage. And that place, that jumping off point that NASA is going to provide is called Gateway. It's going to be like a mini space station that's out near where the moon is, where we can send supplies. Companies can send their landers. It'll be like a staging base or a beachhead for exploration around the moon. And it has several specific parts in it that are different in the lander. If you look here, circled in yellow is an oceanal lander, like the ones I just showed you. In light blue is the Orion spaceship I already talked about. Again, Glenn Research Center has a lot to do with the service module, with the wings and the cylindrical part of Orion. We'll bring rockets up that will drop off logistics, food and fuel and things that the astronauts need. But a key point of it is what's called the power and propulsion element, which is not only the thing that provides all the electricity, all the power, but maneuvers this thing around the moon. It will test a very new type of power a new type of propulsion, very different from chemical propulsion, again, developed at Glenn Research Center, which is called electric propulsion. And this is, again, with this theme of power and propulsion, the specialties at Glenn Research Center is a major element that Cleveland is going to be supplying to this base, this gateway that's in the vicinity of the moon. So here's a little information about that power and propulsion element. We're doing it with a company in California called Maxar that builds communication satellites, although they have subcontractors all through the United States. We're working with them to get all the design details done to make sure it's safe, it meets all of NASA's needs. And we're also providing the technology that will let them put this solar electric propulsion, which you see as these blue streaking lines in this, that'll be used to maneuver this little spaceport gateway all around the areas of the moon to where we need it. This type of propulsion called electric propulsion is very different from combustion. What I will tell you is that it's the most incredible fuel efficiency propulsion for space that anyone's ever found. It means that it doesn't thrust hard, but it thrusts a little bit continuously for a long period of time. It uses very little gas. So that means you don't have to bring as much gas up in order to move around. And you could use that mass to bring up more people or more supplies or more scientific equipment, and you can still move around from space to space. And that's the type of thruster, again, that will probably be used to send people to Mars eventually. So by putting it on Gateway, we can test it out and ring it out way ahead of the point if we ever send people to Mars. As a matter of fact, larger versions of that Gateway with those engines is probably what will get people to Mars in the future. So here's an artist conception of, again, the lander down by the pole, on the south pole of the moon, looking back to the Earth. And you can see the first woman and the next man to walk on the moon, in the bottom of the illustration. And this was for the first mission where they're getting the lay of the land. They've landed outside the crater. They're probably going to go over and do some work inside the crater. And again, the goals for this, unlike Apollo, besides just getting there, is this has to be done sustainably with reusable systems, living off the land so we don't have to bring all the fuel or all the air with us all the time or all the drinking water, in order to merely get access to bring the moon into what I would call America's sphere of economic activity and try to get the value and the wealth of that back for the benefit of our country and the allies that join with us on this effort. Then at that point, the moon will be our furthest beachhead and outpost, not just the International Space Station. And we really believe that from working there, we will learn enough to be able to safely jump off and travel to Mars, which has been a goal that people have had for decades, probably centuries. People thought about somehow we could get to that red dot and see what's there, Mars. That's our big goal after getting to the moon and turning it into our next beachhead and workplace. But there are things we have to do once we start working on the moon. Some of the things that are being done at Glenn Research Center for what we call the sustainability phase beyond 2024, when we really work on the moon, we develop things like supercooled fluids. The reason we deal with those is that there's a lot of things that exist as gases at normal temperature, where you'd like to really use them or store them when they're so cold they turn into liquids. Those are called cryofluids, and Glenn has a big specialty in knowing how to deal with cryofluids. Cryofluids are actually, if you hear about liquid oxygen and liquid hydrogen that power rockets or liquid kerosene, the liquid oxygen and liquid hydrogen is a cryofluid. It means it's super cold, and that's the only way it gets to be a fluid. We do a lot of work in what's called in situ resource utilization, which is a fancy term for living off the land, using the materials that you find on the land. For example, using ice, to melt it and make water, break the water down to make hydrogen and oxygen, or even get oxygen out of the rocks themselves. We know there's a lot of oxygen in the rocks on the moon. We do a lot of work in power. I talked a lot about solar power earlier, but we do a bunch of work even today in what's called radioisotope power, which is nuclear power. And even we're working in fission power, that is nuclear reactive power that we could put on spacecraft or we could put on the moon, which supplies a lot more power than solar cells do. And we work in a lot of other areas. We showed up here solar electric propulsion, which will be used to maneuver around the moon, eventually go to Mars and other destinations. So we have a bunch of work to do in Cleveland to support really putting the moon to working, bringing it within America's economic domain. But having said that, and even though that's probably going to take years and years, even beyond the first landing in 2024, to really make the moon productive is going to take years of work. We are already looking at what is it going to take to send people to Mars. Mars has a different value proposition than the moon does. And Mars is very different than the moon. I show a couple of Mars facts here. It's about half the size of Earth. It's much further away than the moon. At closest, Earth and Mars are like 50 million miles away as opposed to 250,000 miles away. But that's when they're the closest. When they're further apart, Earth is 90 million miles away from the sun, and Mars is 142 million miles away from the sun. So at the furthest apart, you add those together, and that's how far apart they are. Think about what it would take to be confident that you would travel all the way out there the first time, thinking that your equipment will never break, knowing that it would take you 9 months to years to get back if something went wrong. That's the things we're thinking about right now with NASA and with the aerospace industry. How do we get to the point where we're confident that people can safely get out to Mars and get back if there's a problem? Mars has some interesting things. Lower right, it's actually really cold, much colder on average or even at the lowest temperature than it is on the Earth. Lower left, Mars has a little bit of an atmosphere. The moon's just like space. It has no atmosphere at all, vacuum, no air. Mars has atmosphere. It's not breathable air. It's enough of an atmosphere that you can't just zoom down on rockets. It's not enough atmosphere to let you use big parachutes to float down. It's kind of between Earth and the moon. And when you see us land things on Mars, robots today, it is really tricky to land things on Mars. As a matter of fact, the biggest thing we've landed so far has been the Curiosity rover. We have another rover the same size that's going to go down soon called the Perseverance rover. You might have seen they go down with a combination of rocket engines, parachutes, and then we actually use a crane to lower them onto the surface from the air. It's going to take something simpler than that to get even bigger vehicles with people all the way down to Mars. But we'll probably end up going into orbit with people on Mars first to scout it out before we ever go to the surface. But as it is, as I said, you know, getting to Mars, it's going to be tougher. It's probably going to take another 15 years to get us ready to go to Mars, even with what we learn about the moon. We're going to have to bring really big ships. We're going to be traveling really fast. Our crews are going to be spending years away from Earth in weightlessness and places where there are high radiation. We'll have to shield them from the radiation. We'll have to make sure the weightlessness doesn't hurt them. You know, weightlessness over time, if you don't exercise, can hurt your bones and your heart. They're going to be away in weightlessness for a long time. We have to make sure the equipment doesn't break, and if it does, we can fix it. We have to get through that thin atmosphere. And Mars is so far away from Earth that there's a 44-minute maximum time between us radioing the crew and we hearing back from them when Mars is furthest away from Earth. So in effect, they're going to be out there making their own decisions on their own with no control tower being able to work with them. It's actually, what's one of the reasons we need to get to the moon to get ready to go to Mars is that we're so used to operating so close to Earth, and the moon's a little bit further away. There's like a second or so time delay going with a radio going all the way up to the moon. We have to learn not only how to live off the land, but how to really work by ourselves out far away from all the help we're used to getting on Earth. And then, of course, we have to really live off the man when we go to Mars, because if we didn't, we have to haul everything out that we need to get to Mars. We'd have to haul everything out there that we need to get back to Earth, which would just be taking too much stuff out far away from Earth. I was going to stop there. I just wanted to get across to folks that there's a lot going on. There's a lot of things happening with people in space today, and there's going to be even more going in the future. And why it is that the nation is embarked on this. You know, why do we have NASA doing this work? And a lot of that work runs through Ohio. It runs through Cleveland. It runs through Sandusky. You probably read about it every so often in the paper, but there's stuff going on every day at those two locations to try to put space to work for the United States. So I want to thank you for your attention, and I'll be happy to try to answer any questions you have.
Dr. Kearns, thank you so much. It's absolutely fascinating to hear about all the work that is going into this project. And we have had a few questions come in. So to start, are there any new fuel technologies that are going to power the new rockets, and kind of specifically looking at those kind of initial rockets for takeoff?
Yes, there's actually different fuel technologies on the different rockets. For example, the SpaceX rocket that will take the Dragon ship with the two American astronauts up next week actually runs on liquid oxygen and liquid kerosene, but it runs with some very advanced technology and very highly energetic liquid kerosene. So that's even different from the space shuttle that ran on liquid hydrogen and liquid oxygen. The Space Launch System will run on liquid hydrogen and liquid oxygen because we're building a really big rocket and we want to work with a fuel that we understand really well. As I mentioned, the Gateway is gonna run on solar electric propulsion, which is relatively new, at least at the size we're doing it, and the thrust we're doing is relatively new. But we are working on other propulsion technologies that we might use in addition to solar electric propulsion, for example, to go to Mars. We're working on what's called a nuclear thermal propulsion, which is running hydrogen through a nuclear reactor to try to see if that can send our crews even faster to Mars than we could get from electric propulsion or from chemical propulsion, like liquid hydrogen, liquid oxygen. And we're trying to use more environmentally friendly fuels. There are some fuels we use that are actually poisonous, that are long-term storable fuels that in the past would have been used on things like a lunar lander. We're trying to use and test environmentally friendly fuels or fuels that, that maybe pack a lot of energy, but we're not used to using in space, like liquid methane instead of liquid hydrogen or liquid kerosene. And several of the companies that are building those landers, they plan to use liquid methane as the fuel along with liquid oxygen, not just liquid hydrogen or liquid kerosene. So there's a bunch of different things being developed and tested around the United States that will all play into going into the moon and going to Mars.
And with those new technologies, how will NASA deal with those in terms of sharing or licensing for public consumption? Is there a potential to recapture research expenses, or can it be used to fund future projects?
There are two ways in general we do that, although you'd have to go look at the detailed federal regulations to see how that is done. In general, you know, if the taxpayers pay 100% for anything, they own all the data that comes out of it. So that if we build something like a new rocket and the taxpayers pay for almost all of it, and any industry that works with this, they have to give all the data, all the know-how and everything back to NASA, and we make it available to people in the United States. We have to be careful about not making it available to people outside the United States. A lot of the things related to rocketry you could think of as being dual use, which means that an adversary could use that information maybe to build weapons out of it, like a missile. So we have to work with the Defense Department, the State Department, the Commerce Department, even when we get all the information from companies that build things like landers or rockets, to make sure it doesn't get out into the wrong hands. Now, if we work with a company where they are putting money into it, or they pre-declare to us that they have intellectual property that they can show us that they're bringing to this, which the government and the taxpayers didn't have any way to, that did not contribute to, then we make legal arrangements so that we get access to certain types of data, but the company keeps access and it's proprietary for other types of data. So it really gets into the particular thing that's going on. What did NASA, what kind of bounds did NASA set on how industry was going to participate? And what did industry actually propose and bring in? And then when we put a contract in place with them, we have to define all those rules and all those terms and conditions. But in general, as you can imagine, NASA can't communicate to anybody things that other people own or things that other people develop with their own money.
So thinking through potential collaborations, do you have any active collaborations with other nations on initiatives outside of the International Space Station?
Yes, for example, for the Orion spacecraft, the back part of the spacecraft that has all the fuel, the propellant, the power, you know, has the solar cells, it's got the oxygen. It's actually being built for NASA. It's being built for NASA's Glenn Research Center by the European Space Agency, which is the space agency of all the nations of Europe. And the service module itself is actually being built under the direction of Glenn NASA Research Center to the European Space Agency, to their prime contractor, Airbus Defence and Space, in Bremen, Germany. And I was privileged to be the project manager for that for about 2 years when I came to Glenn Research Center. And so we would take industry from the United States that had agreements with Airbus in Germany, and we would bring government officials from NASA and government officials from the European Space Agency, and we would put together the design, and then they were doing the detailed design and the manufacturing of even the service module for the Orion spacecraft, the one that I showed you in the photo and the one I showed you in the schematics. And in addition to that, we think that the internationals are also going to supply components for the gateway, and they may supply their own landers and their own logistic services to go out to the moon. Many nations really want to cooperate with NASA in these major human initiatives to go out to space, and they view how we've cooperated for the space station as being a way to do that in the future. So right now we're off putting together agreements with some other nations on what their roles would be on the gateway. And I wouldn't be surprised if they were going to bring us agreements for roles they would like to have their own landers to get to the moon.
So as we look at the NASA Glenn Research Center here in Cleveland, is the work expanding, is it growing, or is there any risk of potentially losing the center?
Well, I'd say there's no risk of losing the center. Let me say what the center does. We work in 6 areas, and we have work in all 6 of those areas that runs out into the foreseeable future. We do work on airplanes and airplane engines. We do work on spaceship engines and space propulsion. We do work on air and space power. We do work on air and space communications. We do work on experiments in space, when I showed you the photo of the experiments on the space station. And we do work on developing new materials and structures for really unusual environments. Things that are either really, really hot, like Venus or inside jet engines, or really, really cold, like frozen worlds, out in the edge of the solar system. How much money we have and what exact work we're doing waxes and wanes based on what Congress appropriates and what the national goals are. So for example, we have a lot of work right now to build the power and propulsion element for that gateway. And we have a lot of work to keep working with the Europeans on Orion. That's the main work we have related to the things I talked about today. We have work that's starting and living off the land, in situ resources. And we have work that we're doing to build parts of even of the Space Launch System rocket that we're doing with companies outside the United States. So I think we're on a really good path. We have really strong roles. I would say what we have to do now is we really have to deliver on the schedules and commitments we made, because the nation is counting on us to provide our elements out of Ohio so that they can launch from Florida and go to the moon or get up to the space station.
And we have time for one more question. So given that our work is very much focused on leadership development, is there a piece of leadership advice that you would offer from your experiences managing such a complex project that you can share?
Sure. A couple of ones I've seen over the years is remember that you're not going to do all the work yourself as a leader. Your job is to get work organized, and your job is to educate future generations of leaders so they can go do the work and they can eventually get your job. And I would say a lot of times as leaders on a project or as a big organization, we think we personally have to solve everything, that we have to be the smartest person in the room. Well, our job is to get things solved and get stuff delivered. And that means that particularly in complex jobs like I talked about today, that work is spread around many, many people. And what's really important is getting people aligned and orchestrated to hit the right goals and empowering them so they can get the work done for you. Educating them and growing them through leadership development so they turn into leaders of their work groups, their departments, their organizations. The other thing is always to remind people at all levels, they're accountable to get their work done, but they have to go get help if they need it. One of the things that's great about working in NASA is I get to work with tens of thousands of really smart, capable people. And anyone at NASA can go get help from other people. And you want to have a supportive environment like that with your workforce and your leaders and your supervisors so they can get the goals, whatever your goals are of your organization, they know they can reach out and get help and help them get that work done. And people have to make sure they're not afraid to ask for help. It's much better to ask for help than get run into a ditch and realize you can't deliver what you need to deliver.
Well, Dr. Kearns, we thank you so much for your time and the sharing of all that you are working on. And we appreciate kind of the insights into some really great projects that are coming up. And to wrap up, I am going to welcome back Marianne Crosley.
Thanks, Rachel. Dr. Kearns, this was absolutely fascinating, and how terrific to know that our own research center and our talented Clevelanders are playing such a role in advancing our journeys into space. So thank you for all that you're doing and for your commitment and your willingness to share it all with us. And loved the leadership advice in your last few comments. So thank you for sharing that as well. We're very blessed to have you.